Thank you all for joining us this afternoon. Today, we'll be discussing wildfires caused by power lines. SparkStata is a product that was created to dramatically reduce wildfires that are caused from power line malfunctions. Our ultimate goal is to create a robust early detection system that will allow us to get ahead of wildfires. Now, I'd like to introduce you to our team. Our team consists of four different engineering backgrounds that share a common goal of reducing wildfires. We've got Eric Kinian, Yvonne Lopez, Megan Lee, and myself, Pedro Cruz Lopez. Eric will now take over to give us a concise description of wildfires caused by power lines.
Thank you, Pedro. It is no secret to anyone living in California that wildfires have proven time and time again to be devastating to our communities, forest, and state economy. Shown here is a map of the various regions that are most susceptible to wildfires in our home state. This was not a matter of if it would happen, but when it would happen, is a direct quote from Cal Fire captain and first responder to California's deadliest inferno, the Camp Fire. The Camp Fire burned over 153,000 acres, greater than the size of Chicago. 18,800 structures were destroyed, including the entire town of Paradise. While the name may be misleading, the cause of this record fire was a faulty power line. Stephen Gomes, who has lived in Butte County his entire life, recalls waking up and having a cup of coffee to see that 1,000 acres had burned in Paradise, and returning to see that 75,000 acres were burned by dinner time. While he was fortunate enough to get out alive, 85 others were not. We compiled the stats for the deadliest, largest, and most destructive wildfires only caused by power line malfunctions in California alone in the last 13 years. The impact is staggering. Nearly 593,000 acres burned, 25,000 structures lost, and 109 deaths that could have been prevented. While the California Public Utilities Commission estimates only about 10% of the state's fires are attributed to power line malfunctions, the cost of damages are still upwards of $2.4 billion. Next, I would like to share a demo of the current approach to detection and introduce our innovative product.
Command centers today consist of qualified personnel that manually monitor live video feed with the intention of locating signs of equipment malfunction and fire. Seen here is Eddie, a live feed monitor. For the duration of his shift, he's to observe and report back to the utility company. Engineers don't like to admit this, but just like systems make errors, so do humans. Scanning the screen all day is tedious and exhausting. The screen full of live feeds acts as a lullaby for personnel lacking their afternoon coffee. Here Eddie heads out for a cup of joe as he believes it's another slow day at the office. If an electrical spark occurs in the forest and nobody is around to witness it, did it really happen? Yes! And now a fire has erupted, beginning to spread through the landscape. If only there was a backup software. Introducing SparkStata, a machine learning approach to monitoring. SparkStata works with Google API abilities to scan video feeds and detect these sparks. As the dataset of images grows, it becomes more accurate. The system spots the spark in the Starletta feed and alerts those at the command center to investigate. From there, the nearest utility company can turn off the power and address the problem immediately. Now a more in-depth look at SparkStata.
SparkStata will fundamentally transform the way we detect malfunctioning power lines with its preemptive machine learning capabilities. Embedded into the current state-of-the-art pan-tilt-zoom fire cameras, Cloud Vision API has enabled us to easily integrate vision detection features within its applications, which include image labeling, object localization, and hazard detection. This powerful pre-trained machine learning technology available through Google's Cloud Vision API allowed us to quickly assign images and classify them into millions of predefined categories. Initially, SparkStata's training dataset specialized in detecting larger sparks that lasted for about 2 seconds and were approximately the size of a small firework. This enabled our algorithm to establish an initial baseline to detect what sparks on power lines look like. After confirmation of a spark is received, an almost instantaneous warning indication is sent to the command station for personnel to evaluate and determine if shutdown is needed. Over time, as more data is received, our integrated system will continue to enhance its capabilities and create an even more comprehensive classification system. The benefits of tapping into a pre-existing system allows for easy integration to the monitoring technology currently in use, which is susceptible to human error. Furthermore, the implementation cost is minimal, and the collection of data and reduction of personnel over time may save the industry up to $1.8 million per year. The real beauty within this system is the improvements over time. SparkStata will only continue to refine its predictions and observations as the dataset grows. On that note, I'll hand it over to Yvonne to discuss further design developments.
Thank you, Megan. Now let's talk about the future of wildfires. The future of wildfires is more dangerous than most people know. Given the current state of the environment, we should expect to see more wildfires in the future. As climate change worsens, so will natural disasters. Increased wind speeds have led to many power line-related fires. Drought and extreme heat waves have led to most brush fires. All of these contributing factors of wildfires will increase with time. Therefore, technology such as SparkStata will become more significant in the future. We hope to improve SparkStata to solve various other problems brought on by climate change. For example, we hope to add a vegetation intrusion system that will detect when vegetation is in direct contact with a power line. We also hope to add an extreme weather prediction system that will allow power shutdowns before extreme weather disasters hit. And lastly, a risk monitoring system that will help with the evacuations through enhanced situational awareness, that will also allow us to monitor fire behavior throughout its containment. And that is the future of SparkStata. Now I will pass it over back to our MC, Pedro.
Thank you, Yvonne. We'd like to again thank you all for your time, and we will now be opening for Q&A.